So in the previous lecture, we have started with the Taylor and Maclaurin series. We have seen how to find out the Maclaurin series of some standard functions. Now we'll see how we are able to find the Taylor series. We have solved some problem based on that also. But let us try some more problems. Okay, so we go for the next problem. So, we have an example. I hope you are able to see this journal. Are you able to see this?
Yes, sir.
Okay.
Yes, sir.
Okay, so we have a function here, and we want to express this function. Okay, in powers of x minus 1. So this is a given function, and we have to express this function in powers of x minus 1. Okay, so which formula will be applicable? First, second, or third?
Taylor's.
Yes, Taylor's we have to apply, but we have given the variant, three variants of formula. So which formula will be applicable? So you can see this, what we have, x minus term. So it is x minus a. Okay, so compare this term with x minus a and see that where we have x minus a. So you can see in the first formula we have x minus a. So the first formula is applicable. Yes. So what we have here, let what is given f of x. Okay. So this f of x is given x raised to 5 minus 5x raised to 4 plus 6x cubed minus 7x squared plus 8x minus 9. Okay, this is a given function. Now we can see we have to express this in terms of x minus a. So if we want it in terms of x minus a, so here the value of a is going to be 1. Okay, the value of a is going to be 1, and hence we have to find out what is f of 1. Okay, so what will be the value of f of 1? So you can calculate this is going to be 1 minus 5 plus you'll be having 6 minus 7 plus 8 and minus 9. Are you getting this? If I put x is equal to 1, okay, then this will be 1 minus 5 times 1 raised to 4 plus 6 times 1 cube minus 7 times 1 square plus 8 times 1, and you'll have here minus 9. Okay, so what this value is going to be?
Minus 6.
Minus 6.
Minus 6. Okay, so this is going to be minus 6. Okay, all of you are getting this one?
Yes.
Yes, sir.
Or is there any different value that you are getting?
No, sir.
No. Okay, that's good. Okay, so we got this f of 1 is equal to minus 6. Now, what is our next task? Go on taking the derivative of this function. So, first derivative will have f dash of x. Okay, so now we can have 5 times x raised to 4 minus 20 times x cube plus this is 18 times x square and minus 14 times x plus 8. Is that okay? Are you getting this derivative?
Yes, sir.
So here we have the derivative of x raised to n is going to be n into x raised to n minus 1. So this 5 will come down, power will be reduced by 1, and this will happen in each case. Okay, so here this 4 will come down, already we have 5, so it will become 20. This 3 will come down, already we have 6, so it will become 18. This 2 will come down, and we have already 7, so it will become 14. This 8 remains as it is. Okay, and now what we have to do next? we have to calculate what is the value of this function f dash at x is equal to 1. Okay, so if I want to calculate at x is equal to 1, what will be this term? 5 minus 20 plus 18 minus 14 plus 8. Okay, so we have 5 minus 20 plus 18 minus 14 plus 8. Okay, so how much will be having this value? What is the value?
-3. Sir, -3.
Minus 3.
There are,
Minus 3.
there are two different answers. So we have to reach to one conclusion. What is that going to be?
-3.
Yes, sir.
Minus
-3.
-3, sir.
-3. Okay. So we got at one place now. Okay. So this is going to be -3. Okay. Now what next we have to do? Okay. So let us find again the derivative of previous function. Okay. So what we'll have here? This will be 20x cube minus this will be 60x square plus this will be 36x and this is -14. So the derivative of it will go 0 as the derivative of -9 was 0. Now what we have next? So the value of this f double dash at x is equal to 1. Okay, so if I put this value 1, then what will be having? This is 20 minus 60 plus 36 minus 14.
18 minus
-18.
-18.
So this is going to be -18. That's good. Okay. Now, next again, what we have to do is we have to find the next derivative. So we got here f triple dash at x is equal to this will become 60 x square minus this will become 120x and this will become plus 36. So we have to calculate this third derivative at x is equal to 1. So what is going to be the third derivative at x is equal to 1?
-24.
-24.
Good, very good. Okay, so you are getting it to be -24. Okay, now again we go for the next derivative. So fourth derivative, what will be having here? This is going to be 120x minus 120. Okay, so what we got here?
0.
0.
Fourth derivative at 1 is equal to 0.
0.
Okay, so here it is easy. Fourth derivative at 1 is going to be 0. Okay, now think of the fifth derivative at x. So it will be 120. What will be the value of fifth derivative at 1?
0.
What is this value? Will be having?
120.
Yes.
120.
So this is going to be 120. That's good. Okay. So we got all the values. What will be the next derivative?
0.
0.
Okay. So next onwards, once you have reached to the constant term, the next terms are going to be 0. Okay. So we don't have to calculate the next terms. Okay. And once you have reached to all the terms and next term is going to be 0. So that means we are able to write the Taylor series now. Okay. So what we can say is by Taylor series. Taylor series expansion we get. So first always write the formula. What is the formula we have? F of x is equal to f at a plus x minus a f dash at a plus x minus a bracket square by 2 factorial f double dash at a plus x minus a bracket cube by 3 factorial and f triple dash at a and plus so on. That's what we have. Okay, so here a is equal to 1. So here a is going to be 1, and hence what we get f of x is equal to f at 1 plus x minus 1 into f dash at 1 plus x minus 1 bracket square by 2 factorial. Yeah. So this is going to be factorial and f double dash at 1 plus what we have x minus 1. The value of a is going to be 1 cube by 3 factorial, and you'll be having f triple dash at 1 and so on the terms. Okay. Now we know how many terms are there, up to 5. Okay. Hence we get. So what we are able to get, f of x is equal to f of 1. Okay. So what is the value of 1? It's going to be minus 3. Sorry, minus 6. F of 1 is going to be minus 6. So we got here, this is minus 6 plus you will be having minus 3 x minus 1 plus you will be having next term is going to be minus 18. So here we have, this is minus 18 and we have x minus 1 bracket square by 2 factorial. Okay, so what do we have here? It's going to be 2 factorial. Then we have minus 24. Okay. So this is going to be by 2 factorial. Then plus this is minus 24. X minus 1 cube by 3 factorial. And plus this is going to be 0 plus x minus 1. So this term which is going to be 0, what is that? It is x raised to 4. Okay, so that is x minus 1 raised to 4 by 4 factorial. Plus you will have the term, this is you're having 120. Okay, this was a 0 term.
120.
It's 120 now. Okay, so we have here is going to be 120 and we'll be having x minus 1 bracket raised to 5 by 5 factorial. Okay, so all the next terms are going to be 0, so that's why we don't write it. Okay, and hence what we get here, we have f of x is equal to, let us simplify. So we can have, this is going to be minus 6, this is going to be minus 3x minus 1 plus this 2 factorial, 2 factorial is going to be 2 itself. Okay, so what this term will be, this will be 2 and 2 we can cancel here, so it will become minus 9 and we'll be having x minus 1 square. And this is minus. Okay, this 3 factorial is going to be 6. So we can write this as 4 x minus 1 bracket cube. Is that okay?
Yes, sir.
Yes.
Okay. Yes. So this term is going to be 0. Yeah, because here we have this is going to be 0. So we got here 0. Now this 5 factorial is nothing but 120. Okay. So this 5 factorial and this 120 will get cancelled and you'll be having the term x minus 1 bracket raised to 5. Okay. So we got x minus 1 bracket raised to 5. Now if we simplify this, so what we get here, f of x is equal to minus 6 minus 3 x minus 1 minus 9 x minus 1 square minus 4 x minus 1 cube and plus we'll be having x minus 1 bracket raised to 5. And this is going to be the required expression, or this is how we are able to express the given function in terms of x minus 1 using the Taylor series expansion. So what we did here, we have used the Taylor series expansion to find the function or to express the function in powers of x minus 1. Okay. So is there any doubt in this question?
No, sir.
Okay.
No, sir.
All of you got this question and answer?
Yes, sir.
Yes, sir.
Yes, sir.
That's good. Okay. Now let us try. Let us see some another. Okay, some another question. So let's go for the another question. Okay, can you verify this? I want you to verify this whether we have got the correct answer or not. So just quickly verify this.
Sir, you are not sharing the screen.
No, I want you to verify. No,
Oh, sorry, sir.
I want you to
So
verify.
can you please repeat what we want to do?
You have to verify whether we have got the correct answer or not. And in the previous lecture, I have given you the hint what to do. You have to put x is equal to 0. Okay, whatever the expression we have obtained, okay, you put x is equal to 0 in that expression and see that you get the constant term in the original expression. Okay, so whatever given in the question, that f of x, okay, you have to put 0, x is equal to 0 in the expression that we have obtained, and if you are able to get the constant term in the given expression, then whatever we have obtained is correct. Okay, so I want you to verify this whether we have obtained the correct expression or not. So whether you are getting the constant term or not, and if you are not getting, then we have to find where we have committed a mistake. Okay, and if you are getting, that means you are correct or you are on the right track. Yeah, I hope you will do that.
sir.
Okay.
Yes, sir. Getting the
Yes, sir,
constant.
it's correct.
Minus
Very,
9.
yes, very good.
Sir,
Very
can I
good.
put x is equal to 1?
If you put x is equal to 1, then what you have to do is you have to find. If you put x is equal to 1, already we are finding about x is equal to 1, so that x minus 1 will become 0. Okay, so what you will get is x minus 1 is equal to 0. So you will get the value f at 1. Okay, so whichever we have calculated at the first one, f of 1 we have calculated. So if you put x is equal to 1, then you will get f of 1. Okay, so easiest way is put the value x is equal to 0 and get the constant. So that is the correct way or easiest way I can say. Got it?
Yes, answer is correct. Our answer is
Very good, very good. So you know now how to verify. That's good. Okay. So let us go for the another example. So now we'll go for the another example. Okay. So are you able to see this expression? Okay.
Yes, sir.
This is
Yes, sir.
I'll read it again. This is expand. Okay, I should be expand 2x cube. Okay, this is x cube here plus 7x square plus x minus 1 in powers of x minus 2. So we have to expand this expression in powers of x minus 2. Okay, so again we have to use the formula 1. Okay, so what we have laid f of x is equal to 2x cube plus 7x square plus x minus 1. And here the value of a is going to be 2 because we want to expand this in terms of x minus 2. So this is the value of a. Okay, so a is going to be 2, and that's why we need to find the value of this function about 2, or we have to find the value of the function at 2. Okay, so if I put x is equal to 2, what is the value you are getting here? So this will be 2 into 2 cube plus 7 into 2 square plus 2 minus 1. So we can have this is going to be 16. Okay. What this is going to be 28. Okay. And plus 2. I can write this as 1 only because 2 minus 1 is going to be 1. Okay. So what this value is going to be?
45.
45.
What is going to be? Is that 45?
45.
Yes. Okay. So that's what we have. Okay. Now, what we have to do the next? We have to find the derivative of this function. Okay. And once we know the derivative of this function, we have to find the value of this derivative also at the same point. So we have f dash of x. So it is going to be 6x square plus you will be having 14x plus 1. And the derivative of this one is going to be 0. Okay, so what we have to do next? We have to find the value of this derivative at x is equal to 2. So again, we have to think here. Okay, so what is the value we are able to get here?
53.
53.
53?
Yes.
Okay,
Yes, sir.
okay, that's good. So what is the next? Next is we have to find the another derivative. So we can have this is going to be 12x plus 14. And hence we have to find out the value of this derivative at x is equal to 2. So what this is going to be?
38.
38.
38. Okay, that's good. Okay, the next derivative. So we have the f triple dash at x, and that's going to be 12. So we got the value f triple dash at 2. What is the value we'll have?
12.
Are you sure?
Yes, sir.
Okay,
Yes, sir.
that's good. Okay, so what will be the next derivative?
0.
0.
Okay, so next derivative is going to be 0, so we don't have to calculate, and hence we can write here. So by Taylor series expansion, yeah, we get here we get. Okay. Now we write the formula. Okay, so always write the formula first. F of x is equal to f at a plus x minus a, f dash at a plus x minus a bracket square by 2 factorial, f double dash at a, and so on the term. Okay. Now, what we'll be having here? So here a is equal to 2, and hence we get, okay. So we get f at x is equal to f at 2 plus x minus 2 f dash at 2 plus x minus 2 bracket square by 2 factorial and f double dash at 2. And this is going to be plus onwards. Okay. Now write down the terms. So we have, we'll be having f of x is equal to, what is the value of f of 2 we have calculated? So it is going to be 45. Yes. So this is going to be 45 plus, what is the value of f dash we have calculated? So it is
53.
Yes. So it's going to be 53 times x minus 2 plus, what is the next value we have calculated? 38.
38.
Okay, so this will be 38 times x minus 2 bracket square by 2 factorial, that is going to be 2 plus, what is the next value? 12. Okay, x minus 2 bracket cube by 3 factorial. Okay, so is there any other value? What happens to this term now? They are terminated because the derivative is going to be 0. Okay, so up to we put the value, we have to write these dots. Once we put the value, we don't have to write these dots in case of finite expansion. If it is infinite, definitely we have to keep these dots there. Okay, Now simplify this expression. So if we simplify this expression, what we have, f of x is equal to 45 plus this is going to be 53 into, okay, x minus 2 plus this 2 factorial will get cancelled. So can we have 19 x minus 2 bracket square and this 3 factorial? What is going to be 3 factorial? 6.
2
This will
times
be-
x minus 2 whole cube.
Yes. So 2 times x minus 2 whole. Okay. So we got this expression as f of x is equal to 45 plus 53 into x minus 2 plus 19 into x minus 2 bracket square plus 2 into x minus 2 bracket cube. So here we got this expression, okay, in terms of x minus 2. Okay. Now I want you to verify this. Okay. So you verify. I hope you know how to verify. So is there any doubt up to 8?
No, sir.
No, sir.
Okay. All of you got this?
Yes, sir.
Verify this expression.
It is correct, sir.
Good. If you verified, then it's good. Okay, that's great. Are you done?
Yes, sir.
Yes, sir. The equation is correct. The solution is correct.
So you got it correct? Good. Okay, that's good. So let us go for the another example. Okay, so now as I said, the application of this Taylor series is to approximate the values. Okay, so let us see how it helps us to approximate the value. Okay, so we go for the another example. Okay, so let us see this example. I hope you are able to read this.
Yes, sir.
Okay. Okay, so using Taylor series, find the approximate value of root of 10. Okay, so we have to find the value of root of 10 correct up to 4 decimal places. Okay, so we go with the solution. Okay, what we have to find out? We have to find out the square root. Okay, so what we'll be having, let f of x is equal to root x. Okay, so what we want to find out is f of x is equal to root x, because we want to find out what is the value of this root 10. So I can put the value of x is equal to 10. But if I put the value of x is equal to 10, am I able to get the value? Okay, so here, whatever the formulas that we have seen, okay, so we have seen the formula in terms of x minus a, we have seen the formula x plus h, we have seen the formula a plus h. Okay, so this is what we have f of, okay, a plus x minus a, and that is going to be f of x. So we have seen this formula f at a plus x minus a, and this is f dash at a, and so on around. This x plus h is what we have seen. Okay, f of x plus h is equal to f of x plus h times f dash at x plus h square by 2 factorial f double dash at x, and so on around. Okay, this will generate the expression or expansion in terms of x minus a. This will generate the expansion of in terms of h raised to n. Okay, and if we simplify this, okay, this will be f of a plus h times f dash at a plus h square by 2 factorial f double dash at a. So this is what will be having. This will again generate in terms of h raised to n, but here a is fixed and h is also fixed, or in other words, these are constants. And so this expression is used for approximation. What expression is used for approximation? This is the formula that is used for approximation. And now, if I want to use this for approximation, I want to find f of root 10. I have to find out what is root 10. Okay. So we want to get the value of root 10. Okay. So root 10 is our target. Okay. Now, this is, I have assumed that f of x is equal to root x. So this we have to write as f of a plus h. So f of a plus h is root 10. That means there is a and there is h. So this is 9 plus 1. So what I can have is, I can have this term will go as a and this term will go as h. Okay. So we know the root of a perfectly, that is root of 9 perfectly. And that's why we are considering a to be 9. And then this h value we are considering to be 1. Okay. So with this function, we have to find this expression. And once we get to this expression, we have to put a is equal to 9 and h is equal to 1 to get the approximate value of this root 10. Okay, so that a plus h will be 10, so a will be 9 and h will be 1. And so we are able to get the approximate value. So whenever we want to find any approximate value, we have to use this expression. Okay, so this is the formula, Taylor series formula that we have to use to find the approximation. So is that clear idea to you now?
Yes, sir.
Have you got the idea what we have to do exactly now?
Yes.
Yes.
Okay. So once we know what we have to do exactly, okay, then now let us see how to do it. Okay. So we have to perform this calculation step by step. Okay. So here we have assumed that f of x is equal to root of this x, and hence we have. So we know the value of a now. So a is going to be 9 and h is going to be 1. Okay. So what will be the value of 9? F of 9. F of 9 means it is going to be root of 9. We know root of 9 is going to be 3. Is that okay? Yes. Okay. So that's what we'll be having. Okay. Now let us see the next term. So what we do the next, we perform the derivatives. Okay. So let us find the derivative, and hence we have what will be f dash of x. The derivative of root x is going to be 1 upon 2 root x. Okay. So the derivative of root x is going to be 1 upon 2 root x. Okay. And hence what we have here, so we have to find what is f of 9. Now it will be f dash of 9. So it is going to be 1 upon 2 root of 9. So root of 9 is going to be 3, and so this will become 1 by 6. Is that okay?
Yes, sir.
Yes,
Okay,
sir.
okay, so good. So I'll write this f dash of x as half of x raised to minus half. Is that okay? Is this okay?
Yes.
Yes.
So it will be easy to understand the derivative. That's why I have written it like that. Okay, so we want to find f double dash of x. So I'm having half, then I'll have minus half, and I'll be having x raised to 3 by 2. Is that okay?
Yes, sir.
Yes, sir.
So f double dash at x is equal to minus 1 by 4, and this is x raised to 3 by 2. So it will be x root x. Okay. See, when you will have x raised to 3 by 2, that means it is going to be 1 upon 1x and x raised to half. So it will become 1 upon x root x. Is that okay?
Yes, sir. Sir,
Okay.
till how many derivatives we have to found it?
Yes, yes, exactly. So we have to go to 4 decimal places. Okay, so that's why we need at least 4 terms. At least 4 terms means we have to go at least 3 derivatives. Okay, and again that should be non-zero. Okay, if something turns out to be 0, then we have to go to next. Okay, so here what we have next? So this is what we got, and hence we have to calculate the value of this f double dash at 9. Okay, so this will be minus 1 upon 4 into 9 into root of 9. Okay, so what we get here, f double dash at 9 is equal to, what you will have here?
Minus
Is
minus
that
1 upon
minus
108.
108? Yes, correct. Okay, so that's what we got. Now we have to move to the next derivative. Okay, so let us try the next derivative. So f triple dash of x is equal to, this minus 1 by 4 is there already, minus half and minus half, so minus 1 by 4. Now the derivative of this term. So is it minus 3 by 2 into x raised to minus 5 by 2? Is that okay?
Yes, sir.
Yes, sir.
Okay. So f triple dash at x is equal to, this minus will become plus. So we'll be having 3 by 8 x square root x. Because we are having x raised to 5 by 2 in the denominator. So x raised to 5 by 2 means 2 full and 1 half. So 2 full and 1 half. So it is going to be x square, and this is going to be root x again. So we are interested in the value of this derivative at x is equal to 9. So we are interested in f triple dash at 9. So we can have, this is going to be 3. Okay, this is 8, 9 square, and this is a root of 9. Okay, so we got here, this root of 9 is just simply 3. Okay, so we have f triple dash at 9 is equal to 3 upon 8 into 81 into 3. Okay, and hence what we get here? We get f triple dash at
648.
1 upon
48.
648. Correct. Okay, so that's what we got. Okay, so now as I said, we have to go for at least 4 terms. Okay, because we are restricted up to 4 decimal places. So 4 terms, 5 decimal places, 5 terms, 6 decimal places, 6 terms like that. Okay, so now just simplify this. Okay, so we got all the terms, and this is infinitely differentiable, so it may be continued up to the time we want. Okay, and hence we can say by Taylor series exponent we get. Okay, so what we are able to get is f of x plus h. Now here we have to use a plus h. Okay. So here we have f of a plus h is equal to, this is the formula that we are going to use. F of a plus h times f dash at a plus h times h square by 2 factorial f double dash at a and so on. Okay. Now here what we can say is, here a is equal to 9 and s is equal to, okay, so we have, okay, f of 9 plus 1 is equal to f of 9 plus, okay, we'll be having here 1 f dash at 9 plus 1 by 2 factorial f double dash at 9 plus 1 by 3 factorial f triple dash at 9 and so on the terms. So these terms are there, but we have not calculated. Okay, so we get having f of 10. So that is root of 10. We are finding root of 10 and we know what is f of x. F of x we have defined root x. So you can see this f of x is equal to root x. So that I can say that f of 10 is equal to root 10. And that's how we'll be having f of 9. So it is going to be 3 plus f dash of 9. So what we can see f dash here, f dash is going to be 1 by 6. So we can write here is going to be 1 into 1 by 6 plus it's going to be 1 by 2, that is 1 by 2 factorial. Now what is f double dash of 9? So it is going to be minus 1 by 108. We got here is going to be minus 1 by 108. And then we can have 1 by 3 factorial. And we get here 1 upon 648. So is that okay? Is this
Yes.
expression okay? Up to it?
Yes, sir.
Okay. So rest of the terms we have not calculated, but they are there. And we are finding the approximate value. That's why we truncate here. Okay. And hence it is going to be root of 10 is equal to 3 plus 1 by 6 minus, this is 1 by 216. Okay. Plus this is 1 by 3 factorial is going to be 6 into 648. Okay, and now I want you to calculate this value. So you can tell me what this value is. It will be 3 point something, but you have
388.
to calculate. Yes, wait. You have to calculate up to 6 digits. Okay, so you can compare it up to 4 digits.
3888. 6 into 648.
Yes, sir.
It is going to be 3.1622.
Sir, 3.1622.
Some more digits. As I said, we have to take the 6 digits, so we can claim that it is correct up to 4 digits. So if you say only 4 digits, then it becomes difficult that how it is correct. So we have to write 4 more digits, so you can claim that it is correct up to 4 decimal places.
Sir, can we use calculator?
1622. What is the next 2 digits?
94.
94. Okay. So this is approximately. Okay. Here we have calculated.
Can we use calculator?
Yes, you can use calculator, but use calculator to calculate these values only. Okay, if you use calculator and then calculate the value of root 10, it will be different. You can check, you can calculate the value of root 10 by calculator. So if you use calculator, then this value will be different. Someone please use the calculator and let me know what is the value.
Sir, on the calculator it is
3.162277.
Yes. So 3.162277. 162277. So you can see this is correct up to 4 digit. Okay, this is what we want to show exactly, that we have calculated correct up to 4 digit. Okay, so error is in fifth digit. Okay, so if you calculate one more term, your 7 will be correct. If you calculate 2 more terms, your answer will go to 77. If you calculate 3 more terms, then your answer will go to again correct to next term. Okay, so you can see the value that we have calculated using Taylor series method. Okay, and the value you have calculated with the calculator. Okay, so you can see it is correct up to 4 digit. Okay, or 4 places of decimal. And that's what we wanted to find. Okay, so you can see we wanted to find this correct up to 4 decimal places, and we got it correct up to 4 decimal places. Okay, so that's why if you write directly the value using calculator, it will not be correct. Okay, but if you write the value using the Taylor series, you will find it the correct approximation. So you can find it is correct up to 4 decimal places. Okay, you got the difference between the approximate and the correct value. Have you got the idea how do we get it correct up to that term?
Yes,
Yes, sir.
Yes, sir.
Okay. Okay. Is there any doubt up to it?
Sir, in exam, can we use calculator for this means values?
Yes, you are supposed to use the calculator. Okay, but you have to calculate the approximate value. Okay, you should not calculate
Yes, sir, yes.
the value and directly say that
True.
this is the value. Okay, so
Yeah,
you
yes,
have,
sir.
you are supposed to use the calculator. Okay, for example, 1 by 648, if you want to find, definitely you need to use the calculator.
Yes.
So several ways you can calculate again this value. Okay. We go for more example. Okay, for this calculation. So now you got idea how to use the Taylor series expansion, okay, to approximate the value. Okay, so let us try one more example. I hope you are able to read this.
yes, sir.
Okay, so the question is using Taylor series, find the approximate value of root of 1.02 correct up to 4 places of decimal. Okay, so we go with the solution. So quickly, can you tell me that 1.02, how you are able to express, and what will be A and what will be H?
A will
A
be
is
1
equal
and
to
H
1
will
plus
be
0.02.
0.02.
0.02.
Yes, yes. All of you got it. So this is going to be A and this is going to be H. So what will be the function? Let f of x is equal to, is going to be a root x. Okay. So it is going to be root x. Now we know what is going to be H and what is going to be A, and hence we'll try to evaluate this. Okay. Now We know A is going to be 1. So what will be f of 1? What will be the value of f of 1?
1.
So it is going to be 1.
One.
Very good. Okay. So f dash of x is going to be 1 upon 2 root x. So what will be the value of f dash of 1? Is it half?
Yes,
Yes.
sir.
Okay. So what will be f double dash at x? So is it 1 by, yes?
Sir, it will be only root or any function can come like sine of
Yeah,
any
any
value.
function, any function. We are having this example, so that's why we are using root.
Okay,
Yeah,
sir.
it can be any function.
Okay.
Okay. So it can be any function. Okay. So it will be minus 1 by 4. What we have here? X root of x. Okay. And hence, what will be having f double dash at 1 is equal to minus 1 by 4. Okay. Now we can have f triple dash at x is equal to, what will be having here? Minus 3 by 8 x square root of x, and hence you'll be having f triple dash at 1 is equal to minus 3 by 8. Okay. So these are the same functions here what you have got. Okay, this minus minus will become plus. So 3 by 8 x square. Okay. And this will become plus now. So this is 3 and this is 3 by 8. We want to find out correct up to the 4 places of decimal. So that's why we have to go up to at least 3 derivatives. If you go for more terms, that means you will go more correct. Okay. So that's what we'll have. Okay. Now let us see what we get here. Okay. So by Taylor series, we can write here hence by Taylor series function we have. So what will be having f of a plus h is equal to f of a plus h times f dash of a plus h square by 2 factorial f double dash at a and so on. So here what we know is a is equal to 1 and h is equal to 0.0. Okay, so that's what we have. Now, what do we got here? Hence, we get okay, so what we'll get here? F of 1.02 is equal to f at 1 plus here you will have 0.02. F dash at 1 plus 0.02 square by 2 factorial f double dash at 1 plus 0.02 by 3 factorial f triple dash at 1 and so on the terms. Okay, so we have, now we'll write what are the terms we have calculated. So f at 1.02 is equal to, this is going to be 1 that we have calculated. So it is 1 plus, it's going to be 0.02. Okay, so what is f dash? F dash is half. So we have half here. Then this is 0.02 square by 2 factorial This is minus 1 by 4. So you can see here it is going to be minus 1 by 4. And then what is the next term? Plus will be having 0.02 cube by 3 factorial, and this is 3 by 8. Okay, so that much we are going to calculate, and hence we can say that this is the number which is root of. So what we are approximating, root of 1.02. So we got here 1. Okay, this is 0.01. Is that okay? 2 can be cancelled easily. Plus, what this expression you'll be having, 0.0004. Are you getting this? This term, 0.02 square. Is that okay?
Yes, sir.
Okay, and then this has to be minus. Okay, as we have minus here, so this will become minus, and this 2 factorial is going to be 2 into 4 is going to be 8. So we can write here 8, and this is plus. Okay, so here you'll be having 0.02 cube. Okay, upon it's going to be 6 into 8, and this is 3. Okay, so now simplify this. So we get here 1 plus 0.01 minus is going to be 0.0004 by 8, and plus 3 will get cancelled. So we'll be having 0.02 bracket cube, and here this 3 will get cancelled, so we'll be having 16 here. Okay, so now calculate what this value is going to be. So we can have square root of 1.02 is equal to
1.0099
505.
505.
505.
50. Okay, so
05.
yes, 505. Okay, that's why I said we write up to 6 digits, so we can compare that how many digits we have got correct. Okay, and we can say this is approximately. Okay, this is going to be approximately. Okay, so now give me the correct value directly by calculator.
At the end,
One-
only 4 is there. 505 at the end.
1.0099.
Everything is same.
Then what is the value?
5054.
504.
504.
504.
Yes.
4.
So you can see how much correct you have calculated. So you have calculated correct up to 6 digits. Okay, we required up to 4 digits. Okay, so that's good. Okay, so this is how you can see that how much accurately we are able to calculate. Okay, using this Taylor series. Okay, so Taylor series is not just an expression to write in terms of x and powers of h all. Okay, but actually it is very useful tool. Okay, so that's what we have. Okay, is there any doubt up to 8? Okay. Is there any doubt up to 8?
No, sir.
No, sir.
All of you got this?
Yes.
Yes, sir.
Yes, sir.
Okay, that's good. Got this. Okay, so let us have another example. Okay, so go with the example. As somebody asked whether we use only this or if we will go for the another one. So let us go for the another function. Okay, so I'll go for another function. Further example. Okay. Do that.
Excuse me, sir.
Yes.
Sir, in question they have given we have to calculate up to 4 places. Then we can round off.
Yes.
Okay.
See, in the question, it is asked that we have to go up to 4 decimal places, right? Okay, so you can round off also. Okay, but why I want you to write the number of the more digits so that it can be compared that you have calculated using Taylor series and not using calculator.
Okay,
Okay.
sir.
So why I am asking you to write down, because you have seen now, if I calculate by calculator, it will be correct up to 4 digits. So what is the guarantee that I have not written this using calculator?
Yes, sir.
Okay,
Thank you.
so when you write more digit, it gives the guarantee that yes, you have calculated it using Taylor series and not exactly calculator. You are going to get the correct answer up to 4 digits, definitely. Okay. Is that okay?
Yes, sir.
Yes. Okay. So we go for the another example. Prove that. Again, sin hyperbolic a plus h is equal to. Okay. So we have sin hyperbolic a plus h time cos hyperbolic a plus h square by 2 factorial sin hyperbolic a plus h cube by 3 factorial cos hyperbolic a and so on the term. Okay. Using Taylor series.
Sir,
Yes.
sir, can you please explain what is hyperbolic?
Yes, for sure. Okay, I'll explain. Okay, so using Taylor series expansion. Okay, hence calculate the approximate value. Hence calculate the approximate value of sin hyperbolic 1.55 if sin hyperbolic 1.5 is equal to. Okay, so we have this value. All right. It's going to be 2.129279 and cos hyperbolic 1.5 is equal to be 2.35209. So this is 0.35209. Okay, that's what we have. So now you can see what we have to find and then how we have to find. Okay, so first of all, we have to prove this series. Okay, so you can see what formula to be used.
F of a plus h is equals
Correct.
to.
So it is f of a plus h. So you can say f of a plus h is equal to sin hyperbolic a plus h. So what will be f of x? What will be f of x?
Sine
Just say
hyperbolic a
X.
plus h.
yes. So it is going to be sine hyperbolic x. Okay, so we can say let f of x is equal to sine hyperbolic x. Okay, now somebody asked me what is this hyperbolic kind of thing. Okay, so I'll go for that also. Okay, so we have the formula sine hyperbolic x is equal to e raised to x minus e raised to minus x by 2, and cos hyperbolic x is equal to e raised to x plus e raised to minus x by 2. Okay, so these are the definitions of hyperbolic functions. Okay, so these are the definition of hyperbolic functions, sine and cosine, sine hyperbolic, cosine hyperbolic. So we read it as some people read it as sine x, and this is cosine x. Okay, so some people read it as sine x and cosine x, or you can easily read it as hyperbolic sine and hyperbolic cosine. Okay, so this is hyperbolic sine, this is hyperbolic cosine. Only here what we have to take care is h is a part of a function and not a part of angle. Okay, h is a part of a function. It is not a part of angle. So if someone writes like this sine hx, but h text with this, then we have to be careful. Okay, h is a part of function. Okay, h is a part of function. It is not a part of the angle. Okay, and that's why we should be careful while writing the hyperbolic sine and hyperbolic cosine. Okay, so this is basic definition of hyperbolic sine and hyperbolic cosine. Moreover, the derivative, we have to be careful as we have to go for the derivative of this. So d by dx of hyperbolic sine x is hyperbolic cos x. Okay, you can verify. And then d by dx of hyperbolic cos x is same as hyperbolic sine x. Okay, so here in hyperbolic functions you won't get minus. Okay, as in trigonometric function. So d by dx of sine. Okay, so if I consider the trigonometric sine x, then it is cosine x. Okay, and if I consider the derivative of cosine x, trigonometric cosine x, then it is going to be minus sine x. But in hyperbolic functions, we have to be careful that the derivative of hyperbolic sine is hyperbolic cosine, and the derivative of hyperbolic cosine is hyperbolic sine. So there is no minus sign. Okay, so there are some properties of this sine and cosine. Okay, and then we can have the relation between these are called circular functions. Okay, these are circular functions, and these are hyperbolic functions. Okay, so basically there is a question why they are called hyperbolic functions, or why these are called circular functions. So the important thing that we need to understand is this circular function satisfy cos square x plus sine square x is equal to 1, and this hyperbolic function satisfy hyperbolic cos square x minus hyperbolic sine square x is equal to 1. Okay, so this identity represents a unit circle about origin. Okay, this identity represents a unique circle about origin, whereas this identity represents a hyperbola. Okay, whereas this identity represents a hyperbola. That's right. These are also called as circular functions, trigonometric functions. These are called hyperbolic functions. So is your doubt clear now about hyperbolic functions?
Sir, so hyperbolic functions have nothing to do with trigonometric functions, right? They are just using the nomenclature of sine and cos.
No, they are related. Okay, they are related. Okay. There is an entire module to understand the hyperbolic functions and trigonometric functions. So they are related. I'll give you the relation. Okay. Yes. So cos hyperbolic Ix is equal to cos x. Sin hyperbolic Ix is equal to I times sin x. And similarly, we can have cos Ix is equal to cos hyperbolic x, and sine of Ix is equal to I times sine hyperbolic x. Okay, so this can be verified that what do we know about the trigonometric function? Okay, so sine x is equal to e raised to ix minus e raised to minus ix by 2i, and cos of
Sir.
x is equal to, just wait, okay, e raised to ix plus e raised to minus ix by 2. Okay, so this is the trigonometric function. This is the trigonometric function, and you can compare and you can see this relation hold. Yes, any query?
Sir, that left one you have written a sine hyperbolic of Ix is equal to minus I sine.
No,
Will come.
this is correct. Sine hyperbolic Ix is equal to I times sine x.
Sir, that I will go down, na? So 1 by I is equals to minus I, na?
We'll check it here. You try to write sine
Okay,
x, okay,
okay,
and then check it.
okay, sir. Got it, sir. Thank you.
Got it?
Yes, sir.
That's good.
Sir, I is iota complex number.
Yes, yes. I is a complex number. So I is root of minus 1. Okay, so this is how the hyperbolic functions and the trigonometric functions are related. Got it? So there are several properties that can be explored. Okay, I hope that will be explored. Okay. So when you will encounter with the complex numbers, okay, definitely that will be explored. Okay. Got this clear now, hyperbolic functions and the trigonometric functions?
Yes, sir.
Okay.
So let us scroll down a little.
Yeah, now we have to go to our problem.
Sir, can you give us a 5-minute break?
Our problem. Okay, so I hope you got the idea of hyperbolic functions. So I hope you
Yes.
don't have any doubt now in a hyperbolic function, right? Okay, so we have f of x is equal to sin x, and you can see this expression that we want, it is in terms of a plus h. So easily we are able to get the idea that what formula we have to use, that is f of a plus h, and hence we can write f of a is equal to, so it is going to be hyperbolic sine of a. Okay, then we find the derivative. So f dash of x is equal to, the derivative of sine hyperbolic is cosine hyperbolic x, and hence we can have f dash at a is equal to hyperbolic cos of a. Now we go for the next derivative of f of x. So we can have f double dash of x, and then the derivative of hyperbolic cosine is going to be hyperbolic sine x, and hence we have f double dash at a is equal to hyperbolic sine a. Okay. Now again we try to find out the third order derivative. So we get the derivative of sine hyperbolic is again cos hyperbolic x, and hence we have f triple dash at A is equal to, what is the term we get here? So it is going to be cos hyperbolic or hyperbolic cos A. Okay, so we got the 4 terms and that are non-zero terms, so that's okay. We are able to write the series now. Okay, so we can write the Taylor series expansion, and hence we write the Taylor series expansion as, so we can say by Taylor series expansion we have, so always write a formula. What is the formula we have? F of A plus H is equal to F of A plus H times F dash at A plus H square by 2 factorial F double dash at A plus H cube by 3 factorial F triple dash at A and so on. Okay, so now we have, so what we'll get here? Sine. We want to express this hyperbolic sine A plus H is equal to. Okay, so it is sine hyperbolic A plus H times cos hyperbolic A plus H square by 2 factorial and sine hyperbolic A plus H cube by 3 factorial and cos hyperbolic A. This is what the expansion that we want to find. Okay, so you can see this is what the expansion that we wanted to find. So we got this expansion. Now see the question what we want. Okay, so we got this expansion. Then hence calculate the approximate value of sine hyperbolic 1.55. Okay, so we have to calculate the value of sine hyperbolic 1.55. If we know that sine hyperbolic 1.5 is this term and cos hyperbolic 1.5 is this term. So can you guess what will be A and what will be H?
A is 1 and
A
H is
1.5.
0.55.
A, see what we have,
1.5.
sine hyperbolic 1.55. Okay, and we know the value of sine hyperbolic 1.5. Okay, so this is going to be sine hyperbolic 1.5 plus 0.05. Okay, because we know this value, we know what happens at 1.5. We want to calculate what happens at 1.55. Okay, so till 1.5 we know. What we don't know is this term. So this is going to be A and this is going to be H. So have you got the idea what is A and what is H?
Yes, sir.
Okay. So once we know what is A and what is H, then we are able to put this value. Okay, so what we can have here? So here A is equal to 1.5 and H is equal to 0.05. We have. Okay, so we get here sine hyperbolic of 1.55 is equal to. So it is hyperbolic sine of 1.5 plus 0.05. Okay, hyperbolic cos of 1.5 plus 0.05 square by 2 factorial and hyperbolic sine of 1.5 plus we have the term, so we can write here 0.05 cube. Okay, by 3 factorial and this is going to be cos hyperbolic 1.5. Okay, so we'll not go for more terms as this 0.05 bracket cube is very small. Okay, so you can say it will be very small. So the more terms if we will take, they will be very small. And that's why we neglect them. and already the values given are up to 6 digits. Okay, so here 0.05 bracket cube will reach to 6 digits. Okay, so we try to solve this. What do we have? This is going to be 1292. Okay, it's 2.129279. Okay, plus 0.05 and this term. So it is 2.352409 plus we're having 0.05 square by 2. And here we'll be having 2.129279. Okay, plus you'll be having 0.05 cube by 3 factorial. There's going to be 6, and this is 2.35240. Okay, so I want you to calculate this value. So what we get hyperbolic sine of 1.55. This is equal to we're having 2 point approximate. What is value you're getting? Now we got the value.
1 minute, sir.
I don't know it is right, sir, but 2.249610.
2.2496
9610.
We'll verify with the others. Okay, so let us wait others to calculate. If anybody is getting different than this, then you can tell me. Or otherwise, we'll accept this value.
Sir, I am getting
Sir,
2.24.
2.2500.
Wait,
I'm getting.
wait.
I gone up to 8
2 point-
digits plus
2.25.
2500. No, sir, only one time 25.
Okay. 2500, right?
Yes, sir. 250051.
51. Okay.
So I am getting the first one.
The first one.
First one.
The first one I'm getting.
Yeah,
First
sir.
one.
It's first one.
2.249610.
Sir, should we have to add more decimal places?
No need, because they have given us already 6 digits, so 6 digits is sufficient for accuracy.
Yeah, okay.
Okay, so 6 digit is sufficient for accuracy. If they have mentioned 4 digit, then we write 6 digit. Okay, if they have already given 6 digit, then we don't have to go more. Okay, so I'll give you the accurate value is, okay, so accurate value is 2.249611. This is the accurate value. Okay, and see the approximation that we have done. Okay, so this is the approximate value, this is the accurate value. So that means we are correct up to 10 raised to minus 5. Okay, which is very good. Okay, so this is the accurate value. This is the approximate value, even though you can calculate the accurate value by using your calculator. Okay, there is a function hyperlink you have to use it first, and then sine you have to calculate, and then you can write 1.55 and you will get the answer. So yeah, 2.2497. This is also a good approximation, no problem. If you take more terms, you will get more correct. And I have given you the correct value also, and what we have approximated, that's also very good. Okay, so is there any doubt in this example now?
No, sir.
Oh, sir.
Okay, all of you got this?
Yes, sir.
Okay, so will you able to solve the problem based on the Taylor series and Maclaurin series?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Okay. So approximations problem also you will able to solve.
Sir, what is the name of this chapter? Means whole module.
This whole module has the different topics. Okay, so first we have been to successive differentiation. We call it as. Then we have been to expansion of functions. Okay, in expansion of functions we have two types: the Maclaurin series and Taylor series. In successive differentiation, we have calculated the nth derivative of product, and n plus r derivative. Okay.
Yes.
As per your syllabus, this is module 1.
So the whole chapter do not have a specific name like vector space or
Yes,
anything.
yes, yeah.
Okay, sir.